many people. So I think I have to thank Sean for that. I guess most of you already kind of have a clue what OpenMoko is, otherwise you wouldn't be here. So I'm going to let Sean go into the details, and I hope you will all enjoy his talk. Please,
Great.
Sean.
Okay. First off, thank you for coming. A lot of people. Today's talk is probably going to be not what you're used to. It's not incredibly technical, but I brought a technical guy here who's going to talk about it a bit too. So let me just get started. Okay? So I used to talk about this OpenMoko project in terms of this table right here, right? You had this PC industry, and I would say stuff like the hardware, the inputs, all more or less been standardized. But the most important thing is this GUI, this paradigm that if you're using a Mac, you're using Linux, you're using Windows, it's all more or less the same. Okay. And because of this sort of more or less the sameness, you have this web browser, and you have the idea of vertical applications. Like depending upon what job you do, all your applications are different. And this makes way to services. Okay. And when you have services, this is when you really can create an economy. You really can create an ecosystem. Okay, so for the longest time, I thought of this problem that's the problem with the mobile industry, if you will, is that there was no open solution at all in that GUI layer, in that OS stack layer, if you will. But then I realized that if we view this as just a problem, an engineering problem, if you will, waiting to be solved, then we will solve it. We will create a phone that is essentially a PC. And if you think about this for a second, the PC is this 1960s vision of how technology should be. And so we would be solving the problem, but we would fail to create new forms of computing. So today's talk is really about creating new forms of computing. And so if all we do is mimic the PC, we have won that battle, that very, very last screen, that hole, we would fill that in. But we would lose the war. So how do we create new forms of computing? Okay, this is the topic for today. How do we create new forms of computing? And who is in charge? Or better yet, what is in charge? So here's how to be God. The key to making complex neoforms, I will call them today, is from simple systems is first off, you have to have access to the building blocks of the system. These are the amino acids, if you will, of chemistry and biology, and these are the atoms in physics. And you have to have freedom to write new rules. These two things, access to the building blocks, freedom to write new rules, if you want to create new systems. And so let's take an example. Big fleas have little fleas on their backs to bite them, and little fleas have lesser fleas, and so on ad infinitum. This is the idea of starting small and iterating. So we have this first form, if you will, very simple shape. Sometimes these simple shapes are what create the most interesting things, and you iterate. This is what the first iteration looks like graphically. We do it again. This is sort of like the second iteration, if you will. So where are we going? Okay, these are the building blocks. You have building blocks now. You need rules. So these are some very basic rules. If you use these rules, you can draw things like this. Okay, very, very simple things. But it can get more complex. Okay, this is almost looking like, I don't know, a branch or something. And more complex. This is a fern. Okay. And finally, you can get to paintings almost. So we started with one small shape, and we started with a collection of rules. We got this. But these are all closed systems, and closed systems lead to controlled, predictable environments. You will not get new species, you will not have neos, you will not have punctuated equilibriums. Neos, these these new things, right? They initially look like mistakes, genetic errors, if you will, like fucked up systems. And the only word I can use is fucked up systems. But they survive after a while, and they outperform. Some of them die, but there's always some that survive. And so if all we do is we recreate the PC on the phone, okay, it will just be another fleet. Okay? You will have this closed system. All you can do is keep making trees. All you can do is keep making branches. We need new species. And so, again, to make these new species, we have to find ways to stand on each other's shoulders. Not necessarily, as Newton said, on the shoulders of our past. We need to stand on each other's shoulders. And so we need mere access. So if you only have mere access to the atoms and rules, okay, these are necessary but not sufficient conditions to create new life forms. You'll have lots of curves that go between these new life forms. Some of them work, some of them don't. And there'll be a combinatorial explosion, if you will, of all different types of possibilities. You have freedom to experiment. But we need collective wisdom and we need imagination to turn these freedoms, these different curves, if you will, into new forms. So this is the software stack that we're working on, okay? And oh, geez.
A few more there.
We actually have a table here. You set a table.
So that's part of the flat part. They have all this space that they are not using now.
That's the optimization of it.
If you flip the table, you can use the space. Yeah.
Be careful.
Yeah.
If someone has a camera, you have to send me a picture because my boss thinks that still he doesn't really understand the concept of the open phone and people would actually want this kind of thing. So send me a picture.
There's space here.
Yeah. Okay, so
where's the waiting list? We can sign it up right now and people will leave.
Okay, so shall we carry on? Can people back there see anything? Probably not, but sorry. We'll try to speak loud. So, this is the stack. Okay. And think of this as this is your atomic axis. Okay? And at this point, I'm going to bring in Mickey. Well, I guess now we can call him Dr. Mickey. And so I want Mickey to spend 10 or 15 minutes and give you more technical details about how these atomic building blocks work.
Probably not that much.
Okay.
But anyway. So, perhaps let's go back to this slide again. So a whole lot of the stack is already there, and we could just use a lot of building blocks from the community. So one thing that wasn't there was GSM daemon. GSM 7.10 multiplexing and stuff just wasn't there. We did that. But that's not what I want to talk about. I want to talk about the OpenMoko application framework. So this is basically split into 4 components. Could you close the door, please? Because this is a core component, this is a UI component, a net component, and a PIM component. Yeah. So the core component is basically about inter-process communication. So that one application has a consistent way to talk to other applications. This also includes device control, so that we have access to parts of the peripherals. And it also includes our idea of application state. So one thing we really want to see in the device is that there's, if possible, no concept of save or load, because it's just application state, which is automatically serialized and graphed when you come back to the application. So another one is the OpenMoko UI, which is our idea of how a common look and feel for a smartphone should look like. Then there's OpenMoko Net. We have a couple of connectivity options on this phone. We have Bluetooth, we have GSM, we have GPS. So it would be nice to have a way for high-level connection queries. For instance, who is around me, no matter whether this is connected via Bluetooth or via GPRS or anything. So that would be an interesting thing to have a high-level connection query API. And then OpenMoko PIM, high-level PIM APIs. I won't go into detail here because this is probably not going to be implemented anyway. Just some code examples. For instance, the IPC API would be like run contacts application. We have a new phone number, so perhaps the dialer of the dialing application would call this. We have a new phone number, please add this 555-273, whatever. Someone called us. And then the contacts application pops up and asks you whether you want to associate this with a name or something. Then a device control API. We have an interesting panel, I think tomorrow, about hardware management. And this is really interconnected because there's still nothing that's totally standardized on embedded platforms. I mean, dbus is something interesting. HAL is something interesting. Is Rob Taylor here? No? Okay, so it's good that I said it. So the idea to have peripheral control, for instance, set the brightness, get the signal strength from any device, any of the RF devices. So this library will use dbus, dbus gdefinings, libgconf, and probably also libgconf switch. Then the OpenMoko UI. We took GTK and added a couple of widget classes defining our idea of the common look and feel. That's really exactly it. Okay, we come back to the look and feel. OpenMoko Net, like I said, is the idea of high-level connection queries. For instance, give me all the file syncs. Give me all entities that would accept files in my region. Or am I at home? This is give me GPS within region, and I have defined the region at home. Or give me a new GSM connection. So with OpenMoko PIM, I thought it will probably never see the light of day because I talked a lot to the guys working on EDS dbus, and I'm a high-level guy. I like a lot of boom in just one line. But they convinced me that EDS dbus is just enough boom in a few lines. So we should just use libebook for the contacts, use libecal for the calendar stuff, and libcamel or tinime, this is not yet settled on, and friends. So forget OpenMoko PIM.
This is still Mickey, but this part is about, so the first part is like, that's the access to the building blocks, all these different functions, and now you need to be able to write your own rules. So, okay, go on.
So this is the OpenMoko user interface, a short overview. We have a top panel area, we have an application area, and we have a footer area. And process-wise, the top panel is one separate process, the application area is one separate process, and the footer area is also one separate process. So the panel is always visible, global for all applications, and we just use the matchbox panel but in version 2. Version 2 is based on GTK instead of libmatchbox as the previous version was, which is nice. Libmatchbox is somehow awkward in some areas. So the creator of Matchbox panel just said, hey, we have this shiny new thing based on GTK, use that. And we did. So it's basically a panel applet plugin host. The individual panel applets are shared libraries, get loaded by the panel host, and then displayed. So then the OpenMoko application. We have 3 kinds of applications. We think there's an interest to run legacy applications, so we support standard x11 legacy applications. They will open probably full screen and overlap status by area and the panel area. And then we have these 2 kinds of applications, stylus applications and finger applications. So the idea is that you don't always have to grab the stylus to do certain things. For instance, the dialer is a finger application. It's just so this is a full screen dialog, which is one of our classes.
These are real device screenshots, by the way.
Oh yeah, for the first time, we actually use actual screenshots in presentations and no longer mock-ups.
That's a very important information, I think.
Yeah.
Really bad idea.
Thanks.
So,
It was good.
light show. OpenMoko footer. It's a simple thing. It's a task manager. It embeds a status bar containing some temporary notification things, and it also contains at the left, to the right area, 2 significant icons that launch the task manager. That gives you access to all the running applications. And on the other side, it's application toggling. Think tab. It toggles between the current and the last active application.
Okay. Yeah, it allows to experiment. It's just that the first part was about having access to the building blocks, and then you need rules, and then you need sort of an easy way to assemble these things. And this is what we sort of call the labs, if you will. So, okay.
Right. And so OpenMoko application development. How to write an application. We're going to see how to write a stylus application and writing a finger application. Actually, we don't see how to do that, but we see what kind of GTK-derived classes we provide. So for the stylus applications, we need to have in mind the top panel and the footer is still there, but since it's technically not the application but other processes, we just left it out here. So this is a typical stylus application, which is split in 4 parts. We have a Moko paint window. This is the enclosing. We have the Moko menu box. This is where the simple stylus and the filter menu can be seen. Then we have what we call navigation widget. A whole lot of applications can be divided in this idea of having a navigation widget where you see all the data records you have, and then you have the part where you can see the details of the currently selected record. And we map this to the details widget. For instance, in this part it's a GTK label, and the navigation widget, which is, for instance, a tree view or something like that. And then we have the Moko toolbox, which provides consistent access to the search button and to some tool buttons. Similarly, the finger applications. So a Moko finger window is the enclosing for finger windows. We have the finger buttons, which are large finger-friendly buttons, really large, 3 types. Then we have the Moko finger wheel, which is our idea of making a finger-friendly scroll bar, inspired by the iPod, I think. What else? And then we have the Moko finger toolbox, nicely sized bubbles, triggering actions. So since we captured these screenshots, we made this one and this one a bit larger. Okay, and we have a couple of other widgets. For instance, Moko Dialog Window, which is a configured class for full screen modal dialogues. We have field widgets, which are, for instance, very useful in database applications like our contacts and our dates, and more.
Okay. So this is feedback, and this is, in my opinion, possibly the most important part of this whole system, is that the whole project, if you will, is divided into these 2 phases. The first phase, phase 1, second phase, phase 2. The first phase is where we target developers, and if you want to buy this device and you're really a power user, we would say okay, but if you're anything else, we'd say wait until phase 2. Phase 1 is basically the bare essentials we think you need if you want to call this a phone. You have a dialer, a main menu, music player, and history. And phase 2, you have other applications, but the main thing is that all those experiments from the lab, what we're really hoping is that we build new species that are not trees. They're not just sort of iterations of the same thing. And so your application can go in there. So these are the finger ones. And then the stylus is sort of divided, again, it's the same thing. It's these 2 phases, phase 1 and phase 2. And contacts, dates, the application manager, this is based on open embedded IPK format. And this is just the idea that you'll be able to really easily download applications into this system. And it's an A screen. So, in 1973, there was this engineer inside Motorola Labs who goes by the name of Marty Cooper. And he invented this thing and made a phone call over cellular networks. And this became the mobile phone. And by making this device, he literally changed the way people could live their lives, changed the way we viewed technology. And so we think that with this system, there is the potential to change this again, but the difference is this time you will write the rules. It won't be a closed system. It won't be operators saying you can't do this. This is an open device. It's an unlocked device. And so, as we like to say, welcome to the new 1973. So the future is open. This is what the device looks like. This is the black one. This is an actual photograph, but of course a screenshot superimposed on it. And the idea is this is the 1973, the new one, and you're writing the rules. So we have a car kit that's going to be available. It has, if you can see, there's this big hole right here to plug in an external antenna, and it has a couple of different charging kits for your car. And this is the hose, whatever you call this thing. We had this thing that we called the hacker's lunchbox, but then I think I'm probably going to change the name because someone told me that lunchbox brings back bad memories of grade school and getting their ass kicked and their money stolen. So I'd love to call it the bomb squad, but I think bomb squad. Anyway, so this is what we're going to be kind of, if you will, high-end OpenMoko. And these are the costs and what you get in here. Okay. And so the standard kit gives you, of course, the phone, a battery, really nice headset, compact charger, a carrying case, stylus, and we'll release pictures of these things soon. lanyard to kind of carry the phone, micro SD card, and right now we're including a 512 meg micro SD card. It'll be slightly bigger to see, and hopefully mess around with some more things. And this USB cable, instruction manual and warranty, but this is going to be a different kind of instruction manual. And then the car kit has this windshield mount that you just saw, a car charger, an external antenna. This hacker's lunchbox, or whatever this name turns into, has a development board. This is so you can debug everything, even down to the bootloader, which is, of course, also open. And an extra battery for you, compact charger, FTC to connect to the JTAG port, shoulder strap, and then this extra debug cable. And probably what you're really interested in, when. So, as most of you probably already know, on February 12th, actually it was February 11th in one time zone, I found out. And so,
Hawaii.
yeah, exactly. So, we opened up our wiki and our Bugzilla and our source, basically everything that we use, besides the things that are under NDA and myself and my boss would no longer have a job. We opened up everything we could open up is there right now, and including lots of things that are unfinished. And me personally, as someone who's like a borderline perfectionist, this was painful. But then after seeing all this, the feedback, all the excitement and everything, Mickey convinced me, by the way, that this just needs to be open now. We can't wait until the device is ready. We have to, go on our promise. So you can thank Mickey, but all of the source code is open there now. And then we had this thing where we were going to release some phones into the wild for free, and that is more or less a checks and balance system. This was also supposed to be at that same time, but we added Bluetooth to this system kind of a bit later on. And this company who was supposed to make the FPC that would connect to the main board completely messed this cable up, which, yeah. So this is delayed, and right now is Chinese New Year, so it's delayed till after Chinese New Year, which is the 26th, the 27th. And then we have to do a little bit of reworking, so I would say really early March. These first devices will go out there, and then as long as we don't hear any, oh my god, this thing doesn't work at all, right afterwards we have the developer's main sale.
Can I ask you about phase 3?
Sure.
My name is Knut Irving, working for Trolltech.
Yes.
And we have a lot of connection with a mobile operator. And the mobile operators tell us that they have kind of two separate parts. One
Yes.
of them is the engineers. They understand open source, they love it.
Yes.
And the salespeople and the manager hate open source, literally. They won't open their GSM network. They will say, oh, we are spreading out open virus or something. It's the FUD. And they are the FUD guys. So what I'm talking about is that even if you get the device, everything is open source, they will kind of put restrictions in the operating network and say you can't connect your device into the infrastructure or operational networks that they have running. So
I understand
do you have something
the question. Yeah.
New for us on
Well,
that?
let me say a couple of things, okay? And then once we finish, we'll have plenty of time for questions. But first off is we are an operator, okay, in Taiwan, and also we have connections with operators in Asia. So obviously it's no problem there. We've talked with lots of operators about this, and they're incredibly excited. They're basically saying, give me a demo device and let's try it, okay? And the reason is because we've divided this, so the GSM part, okay, is proprietary. It's in a module, okay? So you're not able to actually change the GSM stack, the protocol stack, which is what they care about, okay? And so it exports industry standard AT commands, which are then multiplexed by the host, okay, the Linux system. So Linux controls everything. So for the privacy, I guess fans you call them in here, the Linux system controls the audio, controls the GPS positioning, everything, so you don't have to worry about them watching you or stuff like this. And so, but yeah, so let me spend more time answering that question later on because I still have a lot more slides.
Yeah.
Yeah.
Go ahead.
But this device will be out there. And so, so phase one is these developer sales, and then 6 months after these devices get out, roughly 6 months after they get out, we'll have a mass market device, okay? And somewhere in between here, it's looking right now around June, we're going to up the processing power, move to a faster GSM system, and do that other thing that everyone asks. So this will be a really cool device. You have to understand that it costs a lot of money to make a phone, okay? And so during these initial stages, it was really hard to predict sort of how this would be viewed outside of our company. And so we were very conservative and used parts that were in systems we already sell. I should probably give a little background of this company to bring more credibility. This is not a small hobby project. FIC has $4 to $6 billion a year in revenue. We're the other one of those big Taiwanese OEM/ODMs that the one laptop per child guy talked about today. We didn't get that account. We are better. But, and so this is, right now we make and sell around 1 million handsets a year into China. And so we're using the volumes, we're using most of the key components from these other systems to put in here. And so you could get a phone that's unlocked, that's unsubsidized for $350. You have to understand these phones are expensive to make, and also the components in them are quite expensive. And so this hardware refresh, I'm not sure how public we'll be about this, okay? But all the items from the mailing list we constantly take in, we talk about internally, and we try as best as we can to talk about it externally. And so during the next few weeks, you'll hear a lot more about what this is looking like, okay? And yeah. This is their idea that there's some things that just humans are not good at. And so you should never send a human to do a machine's job. Neo, by the way, really isn't from the Matrix, I swear, I promise. I've kind of got this a lot. And
you know that this side is counterproductive then.
It is, but this quote is just so great. You know? Couldn't resist. Because this is sort of like one of the ideas. I'm always traveling, I'm always in different time zones, I'm always trying to get a hold of Mickey, you know? And so I thought, why the heck can't you have a phone if these two systems are open? Why can't my phone look at Mickey's calendar and figure out when he has a space and put a request in there, okay? And says, Sean wants to call you. And then you say, and Mickey says, no, this time is not great. How about this time? And it compares it with my calendar, and then these phones, these Neos, negotiate when we can talk, and then we just talk. So why can't I say, Neo, you know, call Mickey when he and I are both available? And so this means different time zones. This means different, you know, days of the week. Just whenever our calendars work together. Things like these is possible if your system is open. And so let's jump back to this whole idea of the PC. Is that the PC is this maladaptive system. If you look at the PC, okay, it really isn't that open. Okay, and there's two companies who do all of the operating systems. There's two companies who do all the CPUs. They're both monopolies, and I really challenge someone in this room to name one innovative thing that the PCs have done in the last 10 years. It's really hard if you think about it. And the phone is the same way. The phone is this maladaptive system. You can't change it. It's this closed thing. It's worse than PCs in a lot of cases. And so, again, don't be like the PC. Leapfrog the PC. Okay? And achieve what the PC intended, okay? Which is this idea of computing everywhere, of intuitive computing, of being able to kind of touch and move things like you're painting. Okay? This is what we should strive for. And so this is the 21st century opportunity that I see, okay? It's not that very first screen. It's not how do we take the phone, how do we turn it into a PC? That's not the idea. Okay? If we do this, we will succeed, but it's a problem. Okay, we don't want to be, and this is, so for a long time I was an engineer thinking about how to solve this problem. It's not. How do we create an opportunity to create new life forms, to create new neoforms, new systems? Okay, and so we're here right now. We have a simple system. Today, Mickey told you about these building blocks that we have that are going on, all based on free software, free and open source software. I'm sure everyone's heard there is one small binary module, binary library, I should say, in user space. It's out of the kernel space. We wanted to make sure everything that the hardware can do, you could do. Okay? And so we're here. We have freedom to write rules. We have the ability to make new combinations. So how do we get here? How do we get to the point where our devices learn us, not us learning our devices? Okay? And anyone who's ever used PDA, okay, knows that you spend most of your time feeding the PDA. Okay? And so how do we get systems, how do we get devices that are these complex forms? And so we just know, right now we have an idea how these simple systems can evolve into complex forms. And the first is that you have to have open access to the building blocks. This means open access to the hardware, the processors, the input systems, the output subsystems, all the source code, of course. You need open access to rules for combining and controlling these subsystems. And you also need freedom by many to experiment. It's through these experimentations that some methods survive, some methods grow on, and some other ones just die off because they suck. And then, and this is kind of the really interesting part that I think as a corporation we'll be able to really help out with, okay? Is you need a marketplace that rewards success, okay? And this is what OpenMoko provides. The other day I was talking with people about different open source projects, and one of the things that people were most interested in is that we actually do have what I think is a sustainable business model. And the idea is that if you're going to devote your free time, if you're going to be working on some system, it's nice to know that this system will be here in 3 years, will be here in 5 years. And it's nice to know that you will have an audience, okay, that will buy these devices, that will use these devices, that will give you more feedback so you can make new life forms. And so I struggled for a long time, okay? Do we show everyone this slide, okay? This is what we're trying to do. This is why we're using open source. And from the economic standpoint, I told you why from the what do you call this academic standpoint, more or less. We want to create new life forms, but we need to make money to create these new life forms, to keep these new life forms growing, okay? And to make new devices that are much better, okay? And so, in the past, as an OEM or as an ODM company, you would have these big Western brands. We've made notebooks for HP, Gateway, Dell, Fujitsu, Siemens, you name it. We've built their notebooks. We've built their their consumer electronic devices, and it's always this relationship where you have this huge brand and you have this Taiwanese company, okay? And they say jump, you say how high, okay? And so it's this unhealthy relationship where they don't benefit from collective creativity, and we would not benefit from almost anything if you think about it. I mean, it's just someone telling you how to build a device, when to build a device, and they give this to 5 other companies to build the same device and see who's cheapest. Okay? So the idea is that if you have open systems, okay, if you have, and this is where free and open source software comes in so well, it's a bridge, okay? We go out, we find companies working on interesting systems, making new rules, if you will, trying to create new devices, and this year you'll see a couple of really exciting devices that will also run OpenMoko, okay? We can't talk about them publicly yet, but there will be some really neat devices. And the idea is that you have this common base, this common platform, and it runs on more or less common hardware, okay? And these different companies create the new rules, create the new software, okay? If you look at sort of the world, the industry as a whole, okay? In the East, the hardware is very good. In the West, the software is very good. So this is the bridge between these two cultures, okay? Taiwan has absolutely great hardware skills. China makes all the products, okay? I read something like 43% of all phones will be made in China next year. And PCs, I'm sure, is even more, okay? And so how do you bridge these two worlds, these two cultures, if you will, and also create a base that, as this gets better, okay, everyone who uses the device benefits from, okay? So it's this idea of these new rules go in and they change the system, which makes new life forms, which makes new business models, new business opportunities. These are definitely potentially disruptive systems, okay? And this is what we need. If you have the status quo, these big companies, they want controlled growth, because when it's controlled, they can say, hey, next year, I'm going to bump my processor to 300 megahertz. So I'm going to bump my RAM to 2 gigs, okay? What happens if someone says, you don't even need RAM anymore? This is a new system, okay? So this architecture is about creating new systems. And this is why I'll explain it. And this is why I'm showing this our business model today. Because I'm hoping that people will take this OpenMoko base, will take this hardware that we've done, and stick it in different interesting places, okay? And then come tell me and say, look, we did this, we did that. Okay, and I'll say, that's really cool. Let's make a product together, okay? Let's make some device here. We'll help you manufacture it, okay? And we'll partner to sell it. So it turns into some new device. And so this is, yeah, so this is our presentation. And so I guess now's the time for questions. Yeah, I'll let you finish, sure.
Yeah,
Yeah.
I'm sorry to take up your time, but I will just say 2 more things about the GSM issue, because it's kind of, you are enforced to be in closed source. I just want to emphasize that. I have just one more thing that I would say about the competition. I think it's excellent that more companies now open source their telephone stack and get more developers interested, because it should really be open source, and the other part is that it will probably spin off a lot of new development that hasn't been done. And I have a lot of mobile operators telling us, the science department saying, this is a standstill. Nothing is happening. It's kind of locked in. A lot of companies won't open up. By opening up the devices, opening up the software, we will get a lot of new invention out there. Thank you for doing this.
Yeah, let me just make one comment to this. I heard this absolutely brilliant professor speak one time, and he says you have this sort of like chain, if you will, and you have device manufacturers here, you have carriers here, you have these content creators here, and you have these end users here, okay? This big long string. Why not just take the strings, join them in the center, okay? So you get the content creators, people in this room, okay? And this is not content like this DRM infested stuff. These are real content for devices. Put these together and see what happens. So this is really what this is about. It's about making a device that you can rewrite the rules and write new forms, if you will. Yes?
Another question here on this one here.
Yeah.
Could you speak up?
I don't know if you know this application Nokia had on some of their older phones. It was called the Net Monitor.
Sorry? Net Monitor?
Net Monitor, yeah.
Okay.
It was a hidden application in some of the older Nokia phones.
Okay.
So it allowed you to read out a lot of data about the network you were using. And I was wondering whether OpenMoko would allow access to the radio interface that goes beyond the stream of AT commands which you mentioned, but which would allow still to read out that kind of values that the net monitor provided in the past. This might it's not just a theoretical question.
Yeah.
I have some application in mind.
Yeah.
But as you know, the GSM interface is always proprietary. You're not even allowed to open up those characteristics.
Yeah, we can't even give you binaries.
No, I don't think you're even allowed to say which chip you're using.
Oh, sure, sure. Yeah. We're using a chip from Texas Instruments. It's called the Calypso. Okay, and see, the problem is that these things, they just talk over a serial port, okay, and they talk over standard AT commands. There's no other language you can speak to them, okay, and they do have certain proprietary protocols that will do other things, like you can upgrade the firmware, you can do this kind of stuff, but right now, we're definitely not in a position to be able to open that, okay? Not because I don't want to, just we don't have that legal authority to do that. But if this works, if this really starts generating more and more interested users, then you have my word that we'll keep pressing to try to get more and more open components.
It's actually a yes/no question. For building a kind of network, I need read-only access. And will OpenMoko provide that as it stands now?
To the AT commands, or I mean, because the only way you speak to this device is over AT command layer.
Yes, but those AT commands don't go far enough. You need to read out a little more of the registers in order to get all the information about the network.
Yeah.
Maybe it's too technical.
The person you have to ask is Harold.
Okay.
So send us an email, okay? And I'll make sure he answers you. So he's very good at answering people, but no, I mean, to the best of my knowledge, these so they do have a proprietary AT command set, okay? And I think you probably want access to these, okay?
And it's not provided yet.
Yeah, and can't.
Maybe think about mobile PDA and its inside. So the communication that you can do with the most phones at the moment with AT commands from the outside with the PDA, you have inside controlled by Linux.
Yeah, and it stops there.
Yeah.
I mean, you otherwise hack on the system. I don't know if you're going to be able to pick up these commands. Yeah.
I have some facts about that, because we have one mobile operator willingly to give free access to the production network if you are a scientist or a free software developer.
This is not a problem with the carrier. This is not what this is. You can't access that on the GSM subsystem because you don't have the commands for that.
Okay.
Yeah. I mean, any command you have in that, you know, in the open AT commands you can do on this system, but anything outside of that, you have to find a way to reverse engineer it. Yeah. Oh no, of course not. Yeah. I mean, it's an open system. I mean, you're free to go anything you want.
You're afraid that they'll have the governments or whatever register fight with some laws against or restrictions against such
yeah, I mean, there are some carriers in the world that do like whitelisting, where you have to have a device certified for their network to get on their network. But in every continent that I know of so far, wherever there is whitelisting, there is always at least one other carrier that does not whitelist.
So that was like things like this government, the US government, they wanted like to place a backdoor list of example. They always love to have at least some way to monitor what would they see that as a threat to monitor your own
they could potentially put something in the GSM protocol stack, but the Linux host is the one that actually does the communication with that. Yeah. So you should be able to monitor that yourself.
So what they be afraid of that they can no longer tap your phone?
They can tap your phone in the network side, and they are tapping your phone in the network side, so OpenMoko doesn't help you.
Yeah, you can just control that your phone's off.
But it's more like using like whatever.
I just lost the business for your question.
Oh yeah.
What prevents evil vendor, let's call them, evil vendor, from taking the OpenMoko software and running some very nice applications, but they don't disappear anymore?
Oh, I mean, this would just be us having to go sue them.
No. Do you actually, the libraries are...
Oh, you mean writing on top of there? Libraries on, you mean writing applications on top of our libraries that are closed?
Okay.
Yeah, there's nothing. I mean, those are all LGPL. Our libraries are LGPL. Yeah. I mean, what we'll do is we'll just keep the kernel. We'll keep everything in kernel space absolutely open. Okay. And so you have access to the hardware at all times. Now, what people do on top of that, we can't control. Neither do I really want to. I mean, I like the idea of having systems that you're able to do whatever you want to. See what happens. See what comes out of it. Yeah. Any more questions? Yes.
What kind of CPU is are you using?
Okay, so right now we're using a 2410 from Samsung. It runs at 266 megahertz. And for on that roadmap, that last roadmap for phase 2, we'll up that.
Is it ARM or something?
Oh yeah, sorry. ARM 9, yeah. It doesn't have a DSP.
I've got a question about the programming. Is it a C++ or C oriented? Because GTK can be both.
Yeah, we support both.
Yeah, what is the prime mechanism?
Right now we have architected and implemented the framework in C because that's the lowest common denominator. But of course we are looking to provide GKMM bindings as well to our additional libraries.
So both are available.
Yeah.
And because I'm not a GTK specialist, is the way you interact with the library the same as you do in WX widgets or in Qt using a signaling mechanism, or is that different in GTK plus or in GTKMM?
It's more or less the same.
It's more or less
just C implementing G-object. Its idea of doing object-oriented mechanisms in a language that wasn't exactly designed, but it's conceptually the same.
Okay.
I guess you could even run a Qt on the machine if you really wanted.
Yes, sorry.
At the end of the slides,
yes.
about the business model, I got the idea that the proposition was, in the end, you provide the Neo and the OpenMoko model, but if we find a new idea what to do with it and build a community around it, FIC is moving from being an Apple provider to a community provider, so that it would be like, okay, Rockbox asks you, can you make a machine like this? Because, and you would be open to do that in principle.
Yeah, for sure. I mean, this is about being able to get us into new and interesting markets, get us out of just this standard OEM, ODM role. So yeah, I mean, I mean, there's nothing stopping some other company besides FIC from making this device too.
But the idea is especially to get people to form into groups, communities, to buy this directly without HP, Apple, or whatever.
Yeah. Okay. I mean, this is what I'm trying to do. Okay. Make sure this is absolutely clear. What I'm trying to do is to find people doing cool things. Now, I say business. This doesn't necessarily mean business. It's just think of it as a niche. Okay. Whether it's a community or whether it's a company. Okay. And make neoforms. Okay. Yes. Sorry. Yeah. Go ahead.
Okay. So what assure you that another company from Taiwan will not come and make a similar device to Neo and sell that device with your software?
Oh, yeah.
Because I know that was the problem with the Nokia and Maemo, because they didn't want to open the platform. So
yeah, good question. So I can say a couple of comments on this. About 2 or 3 weeks ago, I was in China looking at our factory, seeing this thing ready. And I had it about 3 or 4 hours off, and I went to a museum. Okay? And during the Ming Dynasty, which was only around 200 or 300 years ago, they did this really beautiful porcelain. Okay? And if you saw the porcelain, you would realize that this porcelain was exactly the same. It was copies of another Chinese dynasty, the Tang Dynasty, around 800 years ago. Okay? So built into the blood, if you will, of China is this idea of copper. Okay? And but I don't mean that in a So why open source? Why GPL? Because built into GPL is this notion of copy. It's you get strength from copy. Okay? And so this whole business model is around the idea that I want them to copy. Okay? I thought about it for a long time. Like how do you develop products? How do you develop new technologies in a region that doesn't respect IP? Okay? So this is the idea: is the more copying, the better.
But my question:
Yes.
How do you convince your boss that go into business and the people involved with Maemo and
Yes.
Nokia?
Yes. Okay, cool.
They
cool.
were not able to.
Okay. So you have to step back and put a business hat on for a second. Okay. So Nokia, okay, is a world-class brand. Okay, making, or I should say, designing devices. They don't make devices.
They don't make it.
Okay. So it is not in Nokia's interest to have other people copy and do that, because they have this branding. They want to keep their image, okay, if you will. Whereas we're a device manufacturer, we build phones for people like Nokia. So it is in our interest to have more people copy this for that reason. It's like you have to look at it from the complete opposite point of view, and then it makes more sense. So that's what we're doing here, really.
Okay, thank you.
Yeah. Yeah, sorry.
I have a small question about the hardware of the OpenMoko.
Yes.
I've heard that the CPU actually has some support for hardware acceleration of graphics.
Oh, no.
But
no.
not at all.
No, yeah, nothing.
Not this one.
Yeah.
SOEC 2410.
Okay.
Shared memory architecture. An accelerated frame buffer.
Another little question on the business model side
Yes.
was you mentioned that you are interested in having these niches that basically where you would provide hardware for new development niches. But from what your OLPC guys were saying, you actually need economies of scale for that. So is it actually interesting to have a niche market with also small runs of hardware?
Small runs of hardware, but similar runs of components.
All right.
There's two ways to get volume. Okay? You can make the same exact. Look at what's inside a phone now. Okay, it's this idea of connectivity. It's this idea of having location. Okay? Knowing where your device is, knowing how to get on networks. And so what you put this in, okay, is very, very flexible. So it's similar components. So we will have economies of scale.
The OLPC guys were saying that actually one of the major costs was the injection molding of the plastics and
the injection molding they did, the tooling they did was phenomenally expensive. For a cell phone, and in China right now, no one wants to make cell phone housings because there's no profit anymore at all. It's unbelievably cheap. And so to make different smaller devices, make different housings, as long as they're not like things Apple would want to do with like double injection and really complicated, different processes to make things, it's not that expensive. The tooling in the whole scope of things is not that expensive. Yes. Sorry.
Okay.
I'll do back to you next. Okay.
How about these things which are put behind the not open source? Will these parts will always be in firmware? I mean that.
Which part's that?
These things, for example, GSM. Are these things in firmware or?
I don't know of anyone trying to make an open GSM protocol stack. I mean, I once read that Texas Instruments spent something like $100 million to make that to actually make their protocol stack. And so it's not in their interest to open it.
Yeah.
And then there's also these things with the FCC saying that they have these rules where they won't let an end user change the RF system. So
yeah, but
I think that the best sort of middle ground is you have this standardized layer, you talk with it.
Yeah. That's fine, but the kernel will anyway be fully open.
Oh yes. Oh yeah. Yeah. Back here. Give me 1 second.
Sean,
Yeah.
could you make this the last question?
Oh, okay. Yeah. I'll be around, so we can talk later. Sorry. Yeah. Yes, go.
Do you have any security protocols or sandboxes so the user doesn't in one application and mimic a message box and get the user to send a private text message?
Yeah. For phase 2, we will. For phase 1, absolutely not. We want this to be totally like just see what comes out of it. Okay, so we are working on something like that, okay? But for the first phase, this is targeting developers, this is targeting people who really want to get in there and try to make new rules, and so we'll see what happens. Yeah.
How many devices for the phase 1 you plan to set?
How many can you buy?
Well, we have a full room of people who want to buy it in the phase 1, I think.
I can make as many as you can buy.
Okay, nice.
We're kind of running out of time, so I have to wrap this up. Just a small practical issue, so we can get out of this room easily. I would suggest that people at the door leave first. Please leave for a while until it clears up so that